Okay, here's a question for you. What in the world connects a simple paperclip, our entire planet, and one of those high-tech MRI machines you see in hospitals? Well, the answer is this invisible, super powerful force that, honestly, shapes our world in ways you probably don't even realize. We're talking about magnetism. And today, we're going to pull back the curtain and really figure out how this incredible force actually works.
All right, so let's start at the very beginning. The fundamentals. What are the basic rules that make a magnet, well, magnetic?
I mean, we've all played with magnets, right? They've got this amazing ability to just grab onto certain things, like iron and steel. And every single magnet has two different ends, a north pole and a south pole. You'll usually see them marked with an N and an S.
But here's the cool part. That force isn't just stuck to the magnet's surface. No, it actually extends out into this invisible bubble of influence all around it. We call that the magnetic field, and it's always strongest right at the poles. And this right here, this shows the #1 most fundamental rule of magnetism. See how the lines from opposite poles are reaching out and connecting? That's attraction. But look what happens when you try to push two of the same poles together, like two norths. The lines literally push away from each other. They repel. It's the classic opposites attract. So we use these imaginary lines to kind of see the invisible, to visualize this force. And they aren't just random squiggles, not at all. They follow a super clear path, always flowing out of the North Pole and looping back around into the South Pole. Okay, so here's the takeaway. These rules, they govern every single magnetic interaction out there. The lines always connect opposite poles. The little arrows show you the direction, north to south. They absolutely never cross each other. And wherever you see those lines bunched up really tight, that's your hot spot. That's where the magnet is the strongest. All right, now that we've got the basics down, let's scale this whole thing up. And I mean way up. We're going from a little bar magnet you can hold in your hand to the biggest one we know of, our own planet Earth. Yeah, you heard that right. Our entire planet is basically one colossal magnet. Deep down in its core, there's this churning ocean of molten iron and nickel, and that whole process generates a massive magnetic field that wraps around our world like a shield and stretches way out into space. And what's amazing is that people figured this out a long time ago. We're talking around 200 BCE in China. They found that this one type of rock, it's called lodestone, which is naturally magnetic, would always point in the same direction, no matter how you turned it. And boom, that was the invention of the compass, a total game changer for navigation. Now here's a fun fact that trips a lot of people up. You know your compass? It doesn't actually point to the geographic North Pole, the very top of the globe. Nope, it points to the magnetic North Pole. And get this, that's a completely different spot, and it's on the move. It's currently wandering about 60 kilometers every single year. Crazy, right? And our planet's magnetic field does way more than just guide compasses. It actually protects us. It acts like a giant invisible shield against all this nasty radiation streaming from the sun. And the best part? Where that shield interacts with our atmosphere, we get one of the most breathtaking shows on Earth, the aurora, the northern and southern lights. Just beautiful.
Okay, so natural magnets are awesome, for sure, but their power is always on. You can't just flip a switch. So what if you needed a magnet that you could turn on and off whenever you wanted? Well, that's where things get really interesting, and it's all thanks to electricity.
So this really brings us to the two main kinds of magnets out there. First, you've got your permanent magnets. Think of the one holding up a drawing on your fridge. It's just always on. But then you've got electromagnets. These guys are temporary. They only get their magnetic powers when an electric current is flowing through them. And the idea behind it is surprisingly simple, but absolutely revolutionary. See, whenever electricity flows through a wire, it creates its very own magnetic field around it. So if you take that wire and wrap it around a core, something magnetic like a piece of iron, you can focus all that power and create a really strong magnet that you can completely control. You could literally do this at home. Just take some insulated wire, wrap it tightly around an iron nail, and hook up the ends to a battery. The second the current starts flowing, poof, the nail becomes a magnet. And just as easily, you disconnect the battery, the power's gone, and so is the magnetism. It's like magic. Okay, so being able to turn magnetism on and off. Why is that such a big deal? Well, let's take a look at how this one simple idea has completely, and I mean completely, transformed the world we live in today. Just picture a scrapyard for a second.
You see those giant cranes lifting entire cars? They do it with a massive electromagnet. They can lift tons and tons of metal, and when it's time to drop it, they don't need some clumsy claw. They just flip a switch, cut the power, and the car drops. It's just so incredibly efficient.
Or how about this? A totally life-saving application. Those MRI scanners in hospitals that use extremely powerful electromagnets to create these amazingly detailed pictures of everything inside our bodies, our organs, our tissues, all without ever having to make a single cut. It's a straight-up medical miracle, and it's all powered by electromagnetism.
And the best part is, we can control just how strong these magnets are. We can dial the power up or down. So if you need to lift a whole car instead of just a pile of scrap, just add more loops of wire. Want a sharper, clearer MRI scan? Just pump more current through the wire. Or use a better core, like soft iron. It's a force that we have precise, and I mean precise, control over.
So just how strong are we talking? Well, get ready for this. In 2019, scientists built the world's strongest electromagnet. It was 400,000 times more powerful than one of those little magnets on your refrigerator. I mean, that's a level of force that's almost impossible to even wrap your head around.
So when you think about it, we've gone from a simple paperclip to technology that can literally peer inside our own bodies. We've come an incredibly long way in learning how to harness this invisible force. We can now create magnetic fields hundreds of thousands of times stronger than the one our entire planet generates to protect us. It's just mind-blowing. And it leaves us with one big question. What challenges are we going to solve with that power next?